You can focus anywhere where you want to focus. You can focus it and you can use it, this laser. Okay, these are the differences between normal light and laser light. Okay, so here we will see what in 1916 what Einstein proposed. Okay, so this is the main foundation. This concept is main foundation for the producing laser beam, that is interaction of matter with radiation, or radiation interaction of radiation with matter, whatever you can say. So in 1916, what he proposed Einstein, okay, when light interact with the atoms or matter or material or any object or any material, okay. So there is a three process takes place. Okay, first one is absorption. Okay, first process is absorption process. Second one is spontaneous emission. Okay, spontaneous emission, and third one is okay, this and third one is stimulated emission. Stimulated emission. These three processes takes place when light interact with matter or radiation interact with matter or any material particle. These when light interact with matter or light incident on a matter, there is a three process take place. One is absorption, and is another is spontaneous emission and stimulated emission. Now we will see what are these absorption and stimulated emission or spontaneous emission. See here, first in first figure, this one. Okay, here we are incidenting one light. Okay, one photon h nu energy, that is having energy h nu. We are incidenting on the atoms. We have taken few energy levels. Okay, suppose there are many energy levels. Okay, but here we have taken only two energy levels. There are also many energy levels like this, but here for easy understanding we have only considered two energy levels. Okay, ground state and excited state. Okay, two levels. In the ground state, generally atoms are sit. This is lifetime is very infinity, and also atoms are very stable in the ground state. Okay, that's why atoms always prefer ground state. So here you using the one photon. Okay, you are taking one photon or some light. Okay, incidenting on the ground state atoms. This light will interact with the ground state atoms, and once these atoms gain energy, they can jump into the excited state. Okay, depending on incident photon energy, this will go to the first excited state, second excited state, third excited state. Okay, if you have sufficient energy, you can jump one step or two step or three steps. That is depends on your energy. Okay, here also instead depending on instant photon energy, this atom ground state atoms can go first excited state or second, third, fourth, whatever. Okay, so this is the what induced absorption or just absorption process. Once the atoms in the ground state gain the energy, they will jump into the excited state. Okay, they will go to the excited state. This is the absorption process. Okay. After that, after absorption, atoms are going to the excited state. Okay, now these atoms having some lifetime, or this excited state having some lifetime. It is generally 10 power minus 8 seconds, order of minus 8 seconds. This is very less lifetime, very short lifetime. So because of that one, some of the atoms will come to the ground state again. Okay, they will go to the excited state and again come to the ground state. Okay, these atoms, they are coming spontaneously, or themselves they are coming to the ground state. That's why we are calling spontaneous. Okay, why they are coming spontaneous means the lifetime is very less, that is 10 power minus 8 second. That is very less lifetime. That's why atoms immediately go to the excited state and come to the ground state. Okay, when they come to the ground state, they lost some energy, that is coming as releases in the form of photons. Okay, that is releases in the form of photons. Okay, here see the second figure, I'm just writing second here. This is one and third. Okay, in the second process, see atoms, whatever atoms in the excited state, after certain time, okay, after particular time, they come to the ground state. In this process, they emit a one photon. Okay, if one atom is coming, one photon. If two atoms come to the ground state, two photons will emit. Okay, like that. If 100 photons come to the ground state, here 100 photons will emit. Okay, 100 photons will emit. Each atom emit one photon. Okay, this is the spontaneous emission. Okay, now third process we have stimulated emission. Okay, stimulated emission means here atoms are there in the excited state. the lifetime, suppose lifetime is high, they can stay longer time. To stimulate this atom, to bring these atoms to ground state, you need to give some energy to this atom, then only they will come to the ground state, otherwise they will not come. Okay, so we will see that one here. Okay, we are taking two energy levels. This is ground state, this is excited state. You can write anything whatever you can write. Here atoms are there. Okay, so here also some atoms are there. So these are lifetime, suppose here 10 power minus 4 second, or maybe higher, maybe lower, whatever. Okay, these atoms are staying in the excited state. These are not spontaneously not coming because higher lifetime of this energy state. Okay, now to bring these atoms to ground state, you have to use some external energy. Okay, here we are sending some photons to this atom. Okay, when photons interact with these atoms, okay, when photons interact with these atoms, they will trigger or stimulate these atoms, or they will push to these atoms to come to the ground state. Okay, these photons will push these atoms to ground state, are forcefully, these atoms are forcefully coming to the ground state. Okay, so here these photons, what these are doing, stimulating the atoms in the excited state, stimulating. Okay, whatever external photons are stimulating atoms in the excited state, and after this stimulation, or you can say these external photons are triggering these atoms in the excited state, or photons interacting with atoms in the excited state. These atoms will come to the ground state. Okay, these atoms will come to the ground state. Okay, this is why we are calling stimulated, means these atoms are not coming themselves, they are coming forcefully by external some force. That's why we are calling stimulated emission process. In this process, okay, incident photon also come emit, and also once this atom come from excited state to ground state, they will emit one more photon. So here if one photon comes from excited state to ground state, here two photons will emit. Okay, two photons will emit. Like that, if 100 photons comes to the ground state here. Okay, ground state, here 200 photons will emit. Okay, so why? Because here we are using 100 photons to trigger these atoms. Like that, depends on photons, and depending on number of available atoms in the excited state, we will get the number of emitted photons. These emitted photons will depend on availability of number of atoms in the excited state. Okay, that is the thing. So in spontaneous emission we will get only one photon, but stimulated emission we will get two photons per atom. Okay, is it clear to you these three process? Any doubt?
Yes, sir.
If you have any doubt here, please let me know. And here see, these are basics only, just understand. Once you understand, it is very easy to understand lasing action, and how we are producing the laser beam, that is very easy. Just these are basics. Okay. So here we will see some important features of different processes. Okay, here spontaneous emission. Okay, here atoms are freely coming from excited state to ground state without any external force. Here only one atom is coming ground state, one photon will emit. Okay. So here some features are there. It is very difficult to control. Okay, because these are spontaneously coming. This can go any direction. Okay, suppose if you in your class there is no teacher, you will randomly behave, right? You can sit here and there, and you can do anything. Okay, like that here also, if atoms are spontaneously coming, they can randomly go any direction. That's why it is very difficult to control. And direction also, it will propagate in different direction, and also there is no phase and there is no plane of polarization. Okay, this is difficult to manage or control. Okay, and also here you will get non-monochromatic, or you can say the emitted light is not a monochromatic, or it is having many colors or many wavelengths, and also it is not a coherent. Suppose if your vehicle is, suppose in the night time, if you see, suppose any vehicle is coming, there is a light. This light you can see which where it is. This light is coming. We cannot see clearly because that is not a coherent light. Okay, coherent means the light should come, it appears like it is coming from a point source light, then it is having same phase and same wavelength. Okay, that's why we'll feel it is a single light coming from the single point source, that is coherence means. Okay, and also it will spread in all direction, and intensity also very less in this process. Okay, these are the few important features of spontaneous emission. Now we will go to the stimulated emission process. Here this all light or emitted light will be in, suppose here atoms are coming excited state to ground state by external photon. So that's why incident photon and emitted photon, these are in same phase. Okay, these are in same phase, and if these are in not same phase, we will use some cavity, and we can make it in a same phase, or we can say that. Okay, so and also the intensity is also very high. Okay, we will bring it into, suppose this atom, this light is emitted light is not in same phase, we will bring it in same phase using some optical cavity or resonator. After that, if these are in same phase, the intensity, this will be in this will be in a constructive interference, or you can say these are in high intensity. Okay, intensity also increase if these are photons are in same phase. Okay, intensity also increase or higher, and also these are in same phase, same direction, and also you can say these are plane polarized, or you can say polarized light. Okay, this will propagate only one direction, that's why you are saying polarized light or plane of polarization. This one you can say plane of polarization, polarized, and this is only having one wavelength. Okay, only one wavelength, that is what monochromatic means. Okay, and also this light is coherent and direction intensity high. These are the few important differences between spontaneous and stimulated emission.